And the idea is that you, in effect, build applications that allow you to populate databases of where local beacons are and develop applications that interact with those beacons. So an example here might be that you have a database of beacons on bus stops. And those bus stop beacons will then be able to connect to people's smartphones and give them information about the frequency of buses and when the buses are running on time, and to count the number of people at the bus stops that the bus company knows, well, maybe I need to put on an extra bus on this route because there are more people there, and so on. All sorts of different applications are possible when you have this sort of proximity-based information available. Here are some examples that we've just sort of came up with as demonstrations that are about interacting with content in a local store, or actually listening to local radio stations based upon the fact that you are close to your internet radio with your mobile phone. Or, as I said, transit connections, or information about your particular location inside a larger building where things like GNSS no longer work. This is going to be a huge area of taking GIS and putting it inside the building as opposed to outside the building. A final thought. A lot of this sounds like, yes, just technology for technology's sake, and it might not make that much of a global difference. But let me give you a really concrete example. This is technology I actually have at home now. I have a thermostat that's connected to my Wi-Fi network at home, that thing, and I have a series of smoke CO2 detectors that are throughout my house. Both those devices, as well as being connected to the internet via Wi-Fi, also have proximity sensors, so they can sense if there's anyone at home. So what happens is, during the day, the sensors automatically recognise the fact that no one's home, and this being the UK, we switch the heating off and not heat an empty house. If there's someone at home, it senses the fact there's someone home, and they warm up. I can obviously also control my heating from a mobile phone app. So much, that sounds quite straightforward. But where it gets really clever is over a period of about a month or so, the thermostat learns the thermal characteristics of your house, i.e. how long does it take your house to warm up once the heating is switched on. Turns out for my house it takes about 35 minutes to go from 16 or 15 degrees to 21 degrees. Okay, so it takes about 35 minutes to warm my house up. That thermostat is in constant connection to my mobile phone. Recognises where the mobile phone is, recognises when I'm using public transport, recognises the context of when I'm 35 minutes away from home in the evening, I'm probably on my way home commuting, and it will automatically switch the heating on when I'm 35 minutes away from home, so by the time I get home, my house is nice and warm. Through using this technology in my home, I'm saving about probably 5% of my energy bill, which might not sound very much, but imagine saving 5% of everyone on the planet's energy bill, what a difference that would make. And that's just using geospatial technology, the stuff that we have all built over the last decades, in a way that perhaps is kind of less visible as geospatial technology, but it absolutely is. Thank you very much.